Okay, so let's go ahead and solve this. So I'm going to solve this by trial and error. And in this case, what I've done is I have taken my equation 1 and equation 2, and I've simply replaced ID in equation 1 with the ID from equation 2, like so. Okay, so I end up with VD minus V divided by R plus A e raised to B VD, and the whole thing equals 0. Now, in order to solve it, let me reorganize this a little bit and just bring VD to the left-hand side and clean up the stuff, multiply the whole thing out by R. So if I multiply the whole thing out by R and leave VD on the right-hand side, I end up with this. So VD equals, so I'm going to take V to the right-hand side, so I get V. And then I multiply out by R, and I end up with taking this to the right-hand side, so I get R A e to the B BD on the right-hand side. Okay, so but this is what I get. So this is the equation that I would like to solve. And notice that any value of VD that satisfies this equation will give you an answer. So let's go ahead and try to do this. So let's say we try to go and solve this for the following values of various parameters. So let's assume that the input voltage V is 1 volt. Let's use R of 1 ohm. Let's use the constant A to be a quarter of an amp, and let's use B as 1 volt inverse. Okay. So those are the values that I'm going to use. And for that set of values, I get VD equals 1 minus a fourth e raised to VD. Okay, how do I get that? So VD is 1. I've chosen R to be 1. A is 1/4, and B is a 1. And so this is what I get on the right-hand side. Okay, so I now need to go and solve this equation here, where VD equals 1 minus 1/4 e raised to VD. So any value of VD that satisfies this equation will work. So one approach is to keep trying various values of VD by trial and error and see if for some value of VD that I substitute here, if I get the same value of VD on the left-hand side. If I do, then that is an answer. Okay, that's a trial and error method. I can be a little bit more sophisticated about this and do the following. But before I do it, I just want to caution you that in 6002X, you're not responsible for understanding and learning about sophisticated numerical techniques for analyzing nonlinear equations. So the basic approach that I want to cover here is simply this. So what you can do is let me guess. Okay, let me guess at a value V being 1 volt. Okay, and see what I get for VD. And the basic idea is to find a value that gives me the same value for VD. Okay, so fundamentally what I'm doing is I'm finding what is called a fixed point. Okay, so fundamentally I'm trying to find a fixed point for this equation. So a value of VD on the right hand side should give me the same value of VD on the left hand side, and if so, it must be the answer. So let me try 1 volt and I get 0.3 volts. So clearly 1 volt is not the answer. So I say, okay, let me try 0.32 volts, and I plug 0.32 volts on this side, and what do I get for VD on the right-hand side? So I plug 0.32 volts on the left-hand side, I get 0.65 for VD on the right-hand side. Okay, I get 0.65 for this VD. So, okay, let me try punching that 0.65 for this VD and see what I get. I get 0.52 for the VD on the left-hand side. So, okay, let me punch that into the VD on the left. What do I get for VD on the right? I get 0.58 volts for the VD on the right. So let me plug that in, and I get 0.55 for the VD on the left. And then I plug that into the left. I get 0.56 for the right. And then I plug that into the right, and I end up with 0.56 for the left as well. So notice that I successively kept plugging in values for VD, took the resulting value and plugged that in, and kept going till I came up with a value that yielded the same value on both sides. And so it appears that VD equals 0.56 volts is a solution. Now, in general, this method that I had of successively using the same answer to drive as the input to drive the equation works in some cases. Okay. This has to do with the convergence property of these equations. And again, let's not go too deep, numerical techniques in this course. That's not the focus of this course. So sometimes when you keep plugging these values, you may not converge. It may start diverging, but in this case, it seems to converge. But fundamentally, what I'm trying to do is apply trial and error techniques to get the same value of VD on both sides. So for 0.56 volts for VD, I can now plug that into my equation ID equals A e to the B VD, but I know A, I know B, and I now know VD, and by plugging in these numbers, I get ID equals 0.44 amps. There you have it. There's my solution, and I'm going to use the solution often as we go ahead. So this method is the analytical method. In this method, we use the node method to write out the equations for the circuit, and then simply use analytical techniques to solve nonlinear simultaneous equations, and we obtain the answer.